Step outside tonight if you can and just breathe. Feel the air fill your lungs effortlessly without a single thought required. Feel the ground holding steady beneath your feet. It feels like the most unremarkable thing in the world, doesn't it? Air, ground, warmth, the most basic, boring facts of existence. I need to tell you something that took me decades of studying the rest of the universe to truly understand. That unremarkable feeling, that effortless breath, may be one of the rarest, most fragile achievements in the entire observable cosmos. Throughout my career, I've studied planets, moons, and stars scattered across our solar system and beyond, searching for anything resembling this. And the deeper I look, the more staggering the silence becomes. Nowhere else, not one single place we have ever measured, offers what this one small spinning rock offers you, right now, without asking anything of you at all. Today, we're going to walk through exactly why. And if you want to keep exploring the fragile, remarkable architecture that makes our existence possible with me, make sure you are subscribed, because I do not think you will ever look at an ordinary sky the same way again. Let us begin with something you have probably never thought to be grateful for: the precise distance between the Earth and the Sun. Picture holding a single candle in the middle of an enormous dark field on a winter night. Stand too close and the heat becomes unbearable. Stand too far and the cold swallows you whole. But there exists one narrow ring around that candle, one specific distance, where the warmth settles into something survivable, something almost gentle. Astronomers call this the habitable zone, and Earth sits almost perfectly inside it, close enough for water to remain liquid across most of the surface, far enough that oceans do not simply boil away into space. This alone would mean very little without a second, quieter miracle sitting right above your head every single night, close enough to touch with your imagination. The moon. Most people think of it as scenery, a pleasant light in the sky. But the moon does something far more important than illuminate our evenings. Its gravity gently anchors the tilt of our planet's axis, holding it steady within a narrow, predictable range instead of allowing it to wobble chaotically over millions of years the way computer simulations suggest it would without a large, stabilizing moon nearby. That steady tilt is the entire reason we experience gentle, predictable seasons, rather than sudden, catastrophic swings between extremes capable of sterilizing a surface entirely. Picture a tightrope walker high above a canyon, carrying a long-weighted pole to hold their balance steady. Remove that pole, and even the smallest gust of wind sends them spiraling out of control. Earth's moon is that pole, an almost accidental companion formed, we believe, from a violent collision early in our planet's history that happened to leave behind exactly the right stabilizing weight at exactly the right distance to keep our entire climate from swinging wildly out of balance. Now let us go deeper, literally beneath your feet, to something even more remarkable, something happening right now that you have never felt and never will. Roughly 1,800 miles below where you are standing, a vast ocean of molten iron churns slowly within our planet's outer core, generating something invisible, something silent, something absolutely essential. A magnetic field wrapping the entire Earth in an invisible shield, deflecting the overwhelming majority of dangerous charged particles constantly streaming outward from the sun. Picture a soap bubble, impossibly thin, impossibly fragile, somehow holding its shape against a strong, steady wind. That is essentially what our atmosphere would be without this magnetic shield protecting it, vulnerable to being slowly stripped away. Particle by particle, the exact fate scientists believe befell Mars roughly 4 billion years ago, when its own smaller, faster cooling core stopped generating a field of its own, and the solar wind began quietly peeling its atmosphere away into space, layer by layer, until almost nothing remained. This is the layer of protection most people never think about at all, and I find that both understandable and quietly remarkable. You have never had to think about your planet's magnetic field the same way you have never had to consciously remember to keep your heart beating. It has simply, silently been doing its work for billions of years, standing between you and a hostile universe, without ever once asking for your attention or your gratitude. But even a stable orbit, a steady tilt, and a protective magnetic shield would still not be enough on their own. There is one more piece of this puzzle, quietly working beneath the ground itself, recycling our planet's very surface over unimaginable stretches of time. We call it plate tectonics, the slow, patient shifting of enormous continental plates grinding against each other over millions of years. This process does something almost nobody appreciates, regulating the long-term balance of carbon dioxide in our atmosphere, pulling excess greenhouse gas down into the crust through weathering and subduction, then slowly releasing it back out through volcanic activity, keeping our planet's temperature within a survivable range across hundreds of millions of years, even as the sun itself has grown gradually brighter throughout that entire time. Picture a thermostat quietly adjusting itself, decade after decade, century after century, without a single human hand ever touching the dial. Venus, our closest planetary neighbor in size, appears to lack this same regulating mechanism, and the result sits there today as a permanent warning, a runaway greenhouse atmosphere thick enough to crush spacecraft. Hot enough to melt lead, a fate some scientists believe Earth itself might have shared were it not for this quiet, patient geological thermostat working steadily beneath our feet the entire time, distance from the sun. A stabilizing moon, a magnetic shield, a geological thermostat, layer upon layer, each one silent, each one easy to take entirely for granted, each one we are increasingly realizing disturbingly rare when you actually go looking for it anywhere else. And that is exactly where we are headed next, out across our own solar system and beyond it, to see just how badly every other candidate we have ever found actually fails. Stay with me. We uncovered the quiet, layered architecture holding our existence together. The right distance from the sun, a stabilizing moon, a protective magnetic field, a patient geological thermostat working beneath our feet. Now I want to take you on a tour of everywhere else we have ever looked so you can feel directly just how rare all of that quietly turns out to be. Let us start close to home with the world most often mentioned as our backup plan. Mars. Picture a house still standing but with every window shattered, the roof torn away entirely, the furnace broken beyond repair. You could technically still call it a house. You could not survive inside it for more than a few minutes without help. Mars lost its own magnetic field roughly 4 billion years ago, and with it, over unimaginable stretches of time, most of its atmosphere stripped away by the same solar wind our own magnetic shield deflects every single day without you ever noticing. What remains is a thin, mostly carbon dioxide wisp of air, less than 1% the pressure of our own, offering no meaningful protection from radiation, no ability to hold liquid water stable on the surface, no warmth retained once the sun sets each night. Now travel the other direction, toward Venus, and you find almost the opposite failure. Picture that same house, except every window sealed shut, the furnace stuck permanently at its highest setting, the air inside thick and suffocating. Venus's atmosphere is roughly 90 times denser than our own, composed overwhelmingly of carbon dioxide, trapping heat so effectively that its surface temperature exceeds 800 degrees Fahrenheit, hot enough to melt lead regardless of whether you happen to be standing at its equator or its pole, in daylight or in darkness. Whatever geological thermostat Venus once possessed, if it ever possessed one at all, appears to have failed catastrophically, spiraling into a runaway greenhouse from which there may be no natural return. Push further out, past the asteroid belt toward the icy moons of Jupiter and Saturn, and you find something genuinely fascinating. Worlds like Europa and Enceladus hiding vast oceans of liquid water beneath miles of frozen crust, kept liquid not by warmth from a distant sun, but by the relentless gravitational flexing of their massive host planets. These are, without question, some of the most promising places in our entire solar system to search for simple microbial life. But promising for microbes is not the same as promising for us. No breathable atmosphere exists on their surface at all. Radiation levels near Jupiter, as we have discussed before on this channel, are lethal within minutes to any unprotected human being. And that ocean, however vast, sits buried beneath a frozen ceiling, miles thick, utterly inaccessible to anything resembling ordinary human life. Picture an oasis, glimpsed from a great distance across an endless desert, shimmering with the promise of water. Draw close enough, and you discover it sits locked behind glass, sealed permanently beneath a surface you have no way of breaking through. That is, in essence, exactly what these ocean moons offer us today, tantalizingly close to something meaningful, and yet still entirely beyond our reach. Now let us step even further back, beyond our own solar system entirely, out into the broader galaxy, where astronomers have spent the last 3 decades discovering thousands of planets orbiting distant stars. Surely among so many worlds, something resembling Earth must exist. And in fact, a number of genuinely promising candidates have been found, planets sitting within their own star's habitable zone, roughly the right size, roughly the right temperature range. But here's what those same astronomers have come to understand the more carefully they look. Being the right distance from a star is only the very first, most basic requirement on an extraordinarily long list. Does that distant planet have a large stabilizing moon, the way ours does? Does it have a molten churning core generating a genuine, lasting magnetic field? Does it have active plate tectonics, quietly regulating its atmosphere across geological time? Is its host star stable, or prone to violent flares capable of stripping away a fragile atmosphere entirely? Is there nearby a massive planet like our own Jupiter, its gravity quietly sweeping dangerous comets and asteroids out of the way before they ever threaten the surface below? This growing, sobering realization has a name among scientists: the rare Earth hypothesis, the idea that while simple, single-celled life might plausibly exist scattered throughout the universe, the extraordinarily specific, layered combination of conditions required for complex, intelligent, technological life might be staggeringly, almost uniquely rare, a combination we have not yet confirmed exists anywhere else at all, despite searching thousands of worlds. Picture that same vast, dark desert we imagined at the very beginning of this journey, except now, instead of a single candle, imagine a single grain of sand, indistinguishable from countless trillions of others, except for one quiet, extraordinary fact. Somehow, against every overwhelming statistical odd, every layer of protection managed to align perfectly within that one specific grain, the right distance, the right moon, the right core, the right thermostat. All at once, all together, long enough for something to eventually look up from its surface and begin asking exactly these questions. This may finally explain something we have discussed before on this channel, a question astronomers call the Fermi paradox, the puzzling silence of a universe that should, by sheer numbers alone, be teeming with intelligent civilizations, and yet has never once given us a confirmed signal, a confirmed visit, a confirmed sign of anyone else out there at all. Perhaps the silence is not evidence that life is rare. Perhaps it is evidence that this exact, precise, layered combination we have spent this entire journey walking through is simply far harder to achieve than we ever imagined. A threshold crossed, as far as we can currently tell, exactly once. I want to leave you with something I think is easy to lose sight of, buried underneath all of this astonishing rarity. We are not simply lucky to live here. We are, in a very real sense, living inside the single known success story out of an almost incomprehensible number of failures. Every lifeless moon, every scorched or frozen planet, every silent, sterile world we have ever pointed a telescope toward. And that success story is not permanent. It is not guaranteed to continue simply because it has worked so far. The same fragile balance that makes this planet possible, the composition of our atmosphere, the stability of our climate, the health of the systems quietly regulating all of it, remains something we are, right now, actively capable of disrupting at a pace far faster than anything nature itself has ever thrown at us before. So where does this leave us at the end of our journey together? Perhaps the search for another home among the stars matters less than the simple, urgent task of understanding and protecting the one extraordinarily rare home we have already been given. Every layer we walk through today, the moon above you, the magnetic field beneath you, the slow geological thermostat working patiently under your feet, exists nowhere else we have ever confirmed anywhere in the entire observable universe. Exploring just how remarkable and how fragile our own existence truly is exactly why I do this work and exactly why I wanted to walk through this particular journey with you. If this changed the way you think about the ground beneath your feet tonight, then make sure you are subscribed so we can keep exploring these questions together. Tell me in the comments, honestly, does learning how rare all of this truly is make you more hopeful about our future, or more worried about how carefully we are protecting it? Until next time, keep looking up and keep remembering just how much is quietly holding you up from below.